The night started out like hundreds of other winter nights in Barcelona. Too cold for the Mediterranean, too windy for a calm flight. At the airport, amid the bustle of evening departures, the new Airbus A320 barely stood out, gleaming with the light of parking spotlights. Its panels still retained their factory luster. The interior decoration had not had time to lose its freshness. Luggage was being neatly stowed in the cabin. Flight attendants' heels were tapping in the corridors, and passengers one by one went to their seats, trying to get comfortable in chairs that smelled of novelty. There were 130, 6 of them in total. Someone was returning home. Someone was flying on business. Someone was just hoping to spend a quiet evening in another city. Almost none of them thought about the fact that this 1-hour flight could become not just another destination, but a story that they would remember all their lives. But so far, everything seemed casual and unremarkable. 4 flight attendants were stationed next to them, tired after a long day, but still smiling on duty. Somewhere above, behind the closed cockpit door, 3 pilots were preparing the plane for departure. Inside the cabin, there was a completely different atmosphere, less calm, more focused. The young co-pilot, who was entrusted to lead this flight, looked a little tense, although he tried to hide it behind his professional bearing. 4 years, several hundred flight hours. He knew how to fly this plane, but each new flight still felt like an exam, especially when the captain is sitting in the next chair. A man with thousands of watches in the air who notices every movement, every pause, every microsecond of hesitation in his voice. The captain closely watched how the young pilot went through the checklists, how he interacted with the avionics, how he controlled the switches and parameters. Their conversations were short and businesslike: numbers, confirmations, system checks. But there was an invisible tension behind every word, the same thing that always accompanies flights in difficult conditions, and the training of a pilot who is just learning to feel the plane as confidently as a more experienced colleague. Behind them, in a folding chair, sat the 3rd member of the crew, the co-pilot, acting as an observer. His task was not to interfere, but to monitor the general situation. Air traffic, the weather, radio communications, everything that goes beyond the direct piloting. He was a kind of additional line of defense, eyes and ears that noticed things that other pilots who were busy with tasks might not pay attention to. But despite the abundance of human experience in the cockpit, there was something else. Something that wasn't sitting in chairs, wasn't talking, wasn't moving, but was present in every corner of the airliner. In the dark compartment under the cabin floor, an invisible passenger hummed and vibrated, the same 144 that no one on board was thinking about. The computer brain of the Airbus A320 is a complex network of electronic modules that made decisions faster than a person could realize what was happening. They were created to help, protect, ensure. They were part of the philosophy that an airplane is capable of keeping itself within safe limits. And today, this system worked as usual, imperceptibly, carefully, clearly, almost soundlessly. The plane began to move away from the gate. Against the background of the deep winter sky, its lights looked like small red and white dots, tracing a route among the concrete paths of the airport. Passengers unbuttoned their collars, arranged blankets, and closed luggage racks. Someone was already starting to fall asleep. Someone was looking through a magazine in the pocket of an armchair. Someone was nervously fiddling with a ticket. They hardly thought about the fact that beneath them was a multi-layered organism of steel, composites, and thousands of electronic solutions, each of which could change everything. While the crew checked the taxiing patterns, the captain mentally reviewed the conditions awaiting them in Bilbao. This airport was known for its complex geography, sharp gusts of wind, and meandering streams of air that rolled down from the mountains and could appear unexpectedly. There have already been several incidents there in recent weeks, too many not to remember about it. But today, the flight had to be completed anyway. According to the data, the wind was within the acceptable range. Not comfortable, but acceptable. The aircraft's control system, relying on fly-by-wire, seemed almost an ideal assistant for such a flight. This technology allowed onboard computers to track every movement of the pilots, correct errors, smooth out sudden impulses, and prevent dangerous maneuvers even before they could cause harm. It was supposed to create a safe buffer between man and machine, protecting them from a wrong decision or a sudden gust of wind. And yet, on this cold evening, no one in the cockpit, no one in the cabin, and no one in the control tower knew that this particular system already carried an unobvious, hidden threat. A mistake that you won't see with your eyes, you won't hear, you won't feel. The error embedded in the program code is so specific and so rare that no one could have predicted its manifestation. It's like a quiet glitch in the heartbeat, one that can go unnoticed for years, until one day it shows up at the most inopportune moment. While the engine was revving up before taxiing and the plane was moving to the beginning of the runway, the crew discussed the usual things: takeoff speed, climb, route, expected conditions on approach. It was a standard conversation that moved from one topic to another, rhythmic and calm as breathing. There was no hidden anxiety in him. No one felt threatened. Nevertheless, the cabin space was filled with that special electricity that arises before flying over difficult terrain. A mixture of responsibility, caution, and inner concentration. When the plane began to take off, passengers felt the usual pressure in their backs. The cabin vibrated slightly, as it always does when powerful engines bring the liner to the desired thrust. The young pilot confidently held the center line, controlled the speed, and answered the captain in clear, short phrases. At that moment, it looked like the evening was going to be quite predictable. The plane took off, retracted the landing gear, and rushed into the black winter night. While the lights of Barcelona were decreasing under the wing, no one knew that in an hour the same silence of the night sky would be replaced by panic in the cockpit. Metal deformation, pain, sparks, and grinding on concrete. No one knew that the very 144th passenger of the plane would be an algorithm that, at a critical second, would decide to act differently from what people expect. So far, the flight was going smoothly. The young pilot relaxed his shoulders, the captain prepared the parameters for further descent, and the observer pilot reviewed the data on the wind situation in the Bilbao area. So far, there has been nothing threatening on these values, only numbers that can be explained by the conditions over the mountains. The plane began to climb steadily, moving further away from the illuminated strip and closer to the part of Spain where night winds live their unpredictable lives. The air mass ahead promised nothing unusual, but behind its surface there was a movement that could not be seen on the dashboard in advance. A movement that was already lifting currents above peaks and going down, twisting into invisible vortices. In the meantime, calm down. And the feeling that everything is under control. But this feeling won't last long. While the plane was climbing over Catalonia and entering a short cruising segment, a calm, working environment prevailed inside the cabin. The young co-pilot held the course confidently, although from time to time he glanced at the captain, checking his reaction. He wanted to be precise, not so much because of the responsibility for the hundreds of people on board, but because of the feeling that his every move was part of an exam, albeit an informal one. The captain, on the contrary, looked as calm as possible in the cockpit of an airliner. There was not a single unnecessary movement in his body. His gaze slid gently between the screens, and even when he corrected the students' actions, his voice remained even, almost warm. Behind them, the pilot observer, sitting in a folding chair, noted small discrepancies with forecasts in his mind. The wind gusts at different levels were stronger than expected. Sometimes the instruments trembled slightly in time with the air fluctuations. This was not unusual when approaching the north of Spain, but it was such details, barely noticeable, that sometimes foreshadowed what was not visible in the reports. Meanwhile, the passengers in the cabin have long been immersed in their rhythms. Someone was reading, someone was snapping a belt fastener, someone was anxiously looking out the porthole, trying to make out at least something in the darkness of the night. Only the occasional glimmer of lights on the ground made it clear that the plane was still over land. What none of them realized, as did most pilots around the world in those years, was that the A320 wasn't just following commands. He interpreted them. He decided how much, how fast, and in which direction to move the control surfaces by consulting a set of rules written in the language of computers, not humans. This system worked millions of times without a single mistake. And this was perhaps its main weakness. People tend to forget that a perfectly functioning thing can also fail one day, especially if the glitch is hidden in a layer that is impossible to see with your eyes and impossible to feel with your hands. Outside, the night was getting thicker. When the airliner began a smooth turn towards Bilbao, the faint reflections of light from the clouds seemed motionless, as if the plane was standing still instead of flying at a speed of hundreds of kilometers per hour. On the horizon, a barely discernible line of fog was slowly shifting, and in this thin haze, the wind and gusts that would await them ahead were already being born. The crew began to prepare for descent. On short flights, this stage occurs almost immediately after boarding the cruiser. Before you can relax, it's time to view approach maps, terrain diagrams, and glide path parameters. The young pilot silently flipped through the documents on the screen, out of habit checking, with what he already knew. The captain was watching closely, not interfering, but monitoring every pause in his actions. The weather data they had received just a few minutes earlier indicated a moderate wind. Not perfect, of course, but within the normal range. Still, the captain knew that in Bilbao, the numbers on paper never fully reflected reality. There, the wind can change direction in seconds, can double in intensity without warning, and the terrain creates conditions that no sensor can detect in real time. As the plane began to descend, the vibration increased, not dramatically, but noticeably. The passengers looked up, and someone gripped the armrests more tightly. The young pilot automatically adjusted the course. His movements were confident, but a little more frequent than required. The captain noticed this out of the corner of his eye, but did not interfere. It was a normal tension that arises when you know that the approach will be non-standard. The wind was picking up. Individual gusts hit the hull, causing a light metallic rattle to pass through the cabin. The people in the middle of the plane hardly felt it, but those who were sitting near the wing felt short tremors. Someone took a deep breath. Someone turned to their neighbor with a questioning look. But there was no panic. Everything looked like a completely ordinary flight in imperfect weather. Still, there was a change in the atmosphere inside the cabin. Some parameters were changing too fast. The speed of the gusts sometimes reached values at which, theoretically, automatic protections should have been activated earlier than usual. But so far, everything has remained within the normal range. They began to approach the area that pilots often call the nervous zone, the space where air masses, breaking off from mountain slopes, go down, twist, tear into pieces, and collide with each other. In these places, the air does not flow smoothly. It moves in leaps and turns, sometimes in the opposite direction to what is expected. In such conditions, the aircraft must enter steadily, confidently, with control of speed, altitude, and thrust. And here, the A320 usually helps. Its electronic circuit is designed to keep the aircraft in safe mode, smooth out sudden movements, and keep it on a predictable trajectory. For a young pilot, this was supposed to be a support. But today, everything will be different, because the defense he was counting on will play by its own rules at this particular moment. The descent continued, and now it was becoming noticeable that the plane sometimes shuddered more. There were short but noticeable vertical fluctuations. Each such vibration passes through the body, as if through a string, and inside the cabin it feels like a slight dip. Passengers began to feel the same anxiety when the brain still does not understand what is happening, but the body is already signaling that conditions are changing. In the cockpit, the co-pilot was intently watching the glide path, his fingers sometimes clenching on the handle of the joystick a little more than necessary. Training and adrenaline were mixed. He knew that the approach would not be easy. He knew that here, at this airport, the weather sometimes didn't behave the way it did on the screen. The captain gently prompted. His voice remained calm, but there was already a slight tinge of tense readiness in it. It wasn't fear, but rather an intuitive premonition that the area ahead would require more attention, more control, and more precision. Meanwhile, the plane was entering an area where wind gusts were higher than expected that evening. They were falling down from the mountains so fast that sometimes the instruments barely had time to update the data. At their previous height, such phenomena were rare, but below that, they became the norm. And at that moment, for the first time in the entire flight, a discrepancy began to appear between what a person feels and what a computer sees. At that moment, the A320 was not yet showing problems, but the logic of its operation was already playing a subtle game. Calculations, safety factors, reactions to changes in speeds and angles of attack. All this was happening deep in a system where decisions were made in fractions of a second. As the plane continued to descend, the increasing pressure of the atmosphere was already felt inside, not physically, but emotionally. The sky ahead looked calm, but underneath it were unpredictable air masses that had already begun to shape the events that would occur in a few minutes. And although nothing had disrupted the flight enough to cause alarm, the atmosphere around them was getting thicker, as if the world around the plane was gradually shrinking, preparing the scene for what would soon begin to unfold much faster than anyone would have time to realize. The plane was slowly passing through layers of cold, humid air, and the closer it got to Bilbao, the more noticeable became what is called the breath of the mountains. These streams do not have a clear structure. They are living air clots that can raise and lower the wing so abruptly, as if the airliner falls into an invisible air pit. To maintain stability, the young pilot periodically adjusted course and altitude, his hands almost never leaving the joystick. Sometimes the movements were a little sharper than necessary, but the captain understood that such conditions always make even experienced pilots nervous. Gusts of wind were intensifying, and the instruments were already recording values that indicated that there would be even more unpleasant areas ahead. The dispatchers reported information based on data from the surface, but this data does not necessarily coincide with what is happening on the glide path. On paper, everything looked acceptable. In fact, the plane was flying towards turbulence, which had already dropped other crews that evening. Nevertheless, the crew decided to continue the approach. According to the rules, they had the right. In fact, many people would have already turned away, especially if they know that Bilbao likes to throw surprises at night when the wind blows off the mountains. Slowly, meter by meter, the plane descended. And with every kilometer, the conditions became more unstable. At some point, the airliner seemed to dive into an invisible wave of air. The cabin sagged slightly, the straps on the passengers tightened, and someone screamed in surprise. The young pilot instantly adjusted the pitch, trying to return the plane to its previous trajectory. This movement was quick, instinctive, but slightly excessive. The captain barely nodded. Yes, too abruptly, but the situation is difficult. The pilot watching from behind was silent, but his face became more serious. He saw what usually becomes an alarm signal. The wind speed changed dramatically in short periods. Gusts, vertical shocks, light drawdowns. All this indicated that the liner was already in a zone where every second could bring a new surprise. The first signs of real anxiety began to appear in the cabin. The passengers, who had never faced such conditions before, tried to smile, but those smiles looked uncertain. Those who flew more often opened their eyes slightly, feeling that something was going wrong. The plane was no longer moving smoothly. It seemed to float away, sometimes rising a little higher, sometimes falling a little. All this was accompanied by short pops and vibrations, the characteristic sound when wings pass through turbulent layers. The crew had to keep an eye on the speed. On the dashboard screen, it sometimes jumped up due to a sudden oncoming gust, so much so that the speed alarm was even activated. At another moment, the speed began to drop, as if the plane had suddenly entered a dense stream of air. Such drastic changes required precise actions, precise traction, and constant retention of the glide path. The young pilot tried to be as accurate as possible. He knew that not only his safety depended on it, but also his own assessment. He wanted to prove that he could do it. Still, the slight tremors in his voice sometimes betrayed something he didn't want to show. The tension that rises from within when you feel like you're entering an area where control is an illusion and the atmosphere dictates its own rules. The captain gave short hints from time to time, not commanding, but guiding. Even under such conditions, his voice remained calm. But now there was a subtle hardness inside that calmness. It manifested itself in sharp, precise diction, in precise words which he pronounced a little more quickly than usual. The descent continued, and now, at about 2,000 feet, it became obvious that the landing would be really difficult. The gusts of wind were so unpredictable that even the captain sometimes leaned forward a little in his seat, as if he were balancing with the plane. The instruments showed sharp fluctuations in the angle of attack. Nothing critical, but the very nature of these fluctuations suggested that the wind currents were chaotic, as if they were being twisted by a huge, invisible hand. The passengers hardly heard the words of the crew, but they felt with their bodies what was happening. Some reflexively looked down at the floor, others gripped the armrests tightly. Someone looked out the window, trying to figure out if the earth was close, but saw only blackness and sparse lights below. In such conditions, time feels different. Every second seems longer, as if the plane is moving not forward, but deep into some dark, dense environment. There came a moment in the cockpit when all three pilots felt for the first time that the fly-by-wire system was beginning to interpret their actions a little differently. It wasn't a malfunction, just the increased work of the protective circuits. Sometimes when the co-pilot tried to straighten the bank or lift the nose slightly, the plane seemed to be slightly delayed in reaction. It was barely noticeable, almost imperceptible, but it was enough for the captain to understand that the computer was working at the limit of its algorithms, adding corrections that it considered necessary. But for now, everything remained safe, manageable, under control. An observer from behind closely watched as the pilot steered the plane along the glide path. He saw how sometimes the movements of the co-pilot become a little more abrupt than necessary. He could see the captain barely noticeably reaching for his joystick, more out of reflex than necessity. He saw how the values on the screens jumped as the thin lines of speed and altitude began to shake in time with the gusts of wind. And at that moment, for the first time in the entire flight, even the experienced captain felt a slight inner tension. He knew that flying over Bilbao on nights like this required not just precision, but perfect coordination. He knew that in such circumstances, the slightest mistake could turn into a serious problem. But he did not know, and could not have known, that this evening the role of the mistake would not be played by a human being at all. That it is automation that will make the decision that will change everything. The plane continued to descend, entering an area where oncoming air currents were already interfering with steady movement. Sometimes the liner seemed to be trying to rise higher, as if it was being lifted by an invisible cushion of air. At another moment, on the contrary, it felt like he was plummeting down. The transitions became more and more distinct, and although no one had yet seen the Earth through the darkness, everyone understood that they were already close. The last part of the journey began ahead, the final approach, the point at which all three elements, the wind, the human factor, and the software code, are about to collide. Without warning, without preparation, without a chance to retreat. At an altitude of about 400 feet above the ground, when the runway was only seconds away, the crew turned off the autopilot. In such conditions, manual piloting provided more flexibility, more sensitivity, and more control over how the aircraft reacted to wind gusts. At least that's what it was thought. The young pilot put his fingers on the joystick a little tighter than before, aligning the plane along the glide path in conditions where even a small movement of the hand meant a noticeable response from the metal body. The turbulence increased. The air masses went from bottom to top, from right to left. Sometimes it seemed to push the plane to the side. Each gust was reflected in small but noticeable vibrations of the hull. Passengers were already instinctively pressing themselves against the seats, feeling the work of the belts, and someone was unconsciously holding their breath. And so, for the first time, a short, sharp signal sounded in the cabin, the one that warns of dual input. Audio recording of both pilots touching their controls at the same time. This shouldn't be happening. But at such moments, the human instinct to help, to ensure, to straighten, is stronger than protocol. The captain, feeling the plane moving away slightly, instinctively put his hand on his joystick. It was almost imperceptible, a slight movement of the fingers. He wasn't going to take over the controls, but he wanted to stabilize the student's maneuver. Normally, this would be safe. But today, two separate movements, two nerve signals, two impulses added to each other by an algorithm, will become part of a chain of events that could not be stopped. However, now, at this altitude, at this moment, the plane was still obeying. It was rude, but he obeyed. Both pilots adjusted the position almost simultaneously, returning the liner to the glide path. The wind beat against the hull, but the trajectory was maintained. Nevertheless, despite the small deviations, they were still within acceptable limits. The decline continued. Ahead, the lights of the runway were already visible, but they disappeared and reappeared, as if the air between the plane and the ground was dense, uneven, and vibrating. The altimeter screen counted down the last dozens of feet, and the crew knew that anything could happen now. But they also knew that they had to keep their speed and course perfectly level. At an altitude of about 200 feet, the plane suddenly got into a powerful tailwind. The air mass pushed him from behind, reducing the instrument speed. For the passengers, it felt like a slight sway, barely noticeable. But for the pilots, it was one of the most dangerous moments. When a tailwind strikes so suddenly, the plane may lose lift. It's critical at this altitude. This was followed by an even sharper shift. A strong vertical updraft hit the hull, as if it had picked up the plane from below. In a second, the height began to rise. The young pilot reflexively pushed the handle forward, trying to keep the liner from climbing too sharply, so as not to leave the glide path. He acted correctly. At that moment, it was the only logical step. But the air wasn't going to give in. Almost immediately after that, without transition, without warning, the plane entered a downdraft. It was as if he had fallen several meters down. This feeling immediately ran through the body of every passenger. Someone screamed. The straps pressed into his shoulders. The young pilot abruptly pulls the joystick towards himself, trying to pull the plane out of the hole. And in the same split second, the captain, feeling the same sharp jolt, does the same thing. He also pulls the handle towards himself to lift his nose. And dual input sounds again. Only now, at the most inopportune moment. At that moment, the Airbus A320 was faced with the most dangerous combination. Two people trying to save the car, and software logic written for ideal conditions, not for the chaos that reigned around. The computer received two commands at the same time. In the fly-by-wire algorithm, they add up. And when the teams add up, the system evaluates the final query. How much do the pilots want to lift their nose? And the system decided, too much. It's too dangerous. If you follow their command, the angle of attack will exceed the permissible limit, and the liner may collapse. The automation did what it thought was right. It just ignored both movements, froze the reaction, rejected the command. And at the same moment, analyzing the airflow, she tried to protect the plane from an imaginary threat, from too much lifting of the nose. She did the opposite. She gave commands that lower her nose even lower. And it all happened in a split second. The young pilot pulls the handle. There is no answer. The captain pulls the handle, but there is no answer. Both of them hear a short electronic click in their headphones, indicating that the algorithms are working. But there is no nose lift. On the contrary, the plane starts to peck down. The captain immediately makes a decision: to leave for the second round. He pushes the thrust levers forward, putting them in toga mode, maximum power. This action usually causes the aircraft to soar upward, even if the trajectory is slightly disrupted. But not now. At this moment, in this very brief moment, the liner is already too low. He doesn't have enough height to react to the new regime. The lifting force has not yet recovered. And the algorithm still holds the nose in the position it considers safe, and the lane is approaching too fast. After a split second, the Airbus touches the ground. But he touches it wrongly, with his nose. This is not the kind of soft touch that is prepared for landing. It's a sharp blow that reverberates through the entire structure, like a hammer striking metal. Passengers feel their bodies being thrown forward as the air is knocked out of their lungs. A deafening sound of destruction can be heard in the cabin. The nose rack is flying apart, breaking from overload. The plane bounces off, but does not have time to rise. He falls again, onto the main landing gear, which begins to slide on the concrete. The pilots desperately pull, trying to lift the nose, but the automation holds the same reaction pattern for a moment longer, until the speed drops too much and the protection is turned off. It's too late now. The nose sinks completely. Metal scrapes across the strip. Sparks escape from under the case. Engines cling to concrete. Smoke rises into the air, the smell of burnt metal and rubber. The plane begins to spin. It is pulled away. The tires burst. The liner slides, leaving a furrow in its wake. The cabin is filled with screams, the sounds of falling things, and sudden tremors. None of the passengers understand what is happening. Everything is too fast, too rude, too loud. And finally, a stop. Sudden, sharp, severe. The silence after that seems unnatural. The plane breathes hot air, the smell of oil, smoke. Travelers who a minute ago were only thinking about how to get home are now staring into the darkness of the cabin with wide eyes. In the cockpit, the captain turns off the engines, breathing heavily. His voice is shaking, but he remains in command. And people are running. When the plane finally stopped, the silence wasn't real. It was the silence of pressure in my ears, the silence of stress, the silence after the deafening screech of metal. Small sounds could still be heard inside her. The soft crackling of hot knots, the rustle of things falling from shelves, and the muffled sobs of passengers who were trying to figure out if they were safe. Gradually, voices began to appear in this silence, at first timid, then louder. People were calling each other by name. Someone was crying. Someone was asking what happened. Someone was trying to feel the belt, which was still digging into his shoulders. The cabin smelled of burnt rubber, hot metal, and something else, subtle but unpleasant. The light was blinking. Several ceiling panels were dislodged. The pictures in the cabin looked like shots from a movie. The seats were askew, luggage had fallen onto the aisles, and the air was thick and heavy. The flight attendants began to act almost immediately. A professional reflex worked faster than fear. One of them opened the nearest emergency exit. The cold night air rushed in, mixed with the smell of wet concrete. The dark strip under the wing was illuminated by the flashing lights. No one outside understood how damaged the plane was. But one thing was clear. You couldn't stay in the cabin. Passengers descended the stairs quickly, but without chaos, although panic was literally in every cell of the air. Someone was falling. Someone was being lifted. Someone was screaming. Someone was just silently walking forward in a stupor. On the ground, people were on their knees, kissing the cold concrete or hugging their children. Someone was looking at the liner and couldn't figure out how they all got out alive. Because the impact was so strong that, according to all logical laws, such collisions often ended much worse. Meanwhile, the crew, shaken but active, were the last to leave the cabin. The captain looked around, making sure that no one else was left inside. His face was pale, his hands were shaking, but his movements remained precise, thanks to years of training that teach you how to act, even when you don't fully understand what happened. It was only once on the ground that the three pilots could afford to just stand there. Breathe. Realize. It was as if the tension that had kept their bodies rigid was gradually dissolving, giving way to exhaustion, both emotional and physical. The young pilot looked particularly shocked. His eyes were wide open, and his face seemed to have lost its color. He tried to speak, but the words wouldn't add up. All he could say was, "I pulled on myself." She didn't react. The captain was silent. He saw the same thing. He was doing the same thing. But the plane really wasn't moving its nose up. Gradually, the first rescue vehicles arrived. The blue light from the flashing beacons illuminated the fuselage, leaving long shadows on the concrete strip. Paramedics examined people and helped those who were injured. 25 people were injured. One is serious. But everyone was alive. This thought seemed incredible, especially when you look at the nose of the plane, which was now a dented structure with torn pieces of metal sticking out of it. The fuselage was deformed. The front part of the liner seemed to bite the ground, breaking on concrete. And yet, everyone survived. It was a miracle of design, a miracle of chance, a miracle of luck. And so, in this mixture of stress, fear, relief, and misunderstanding, a new stage began. The stage of questions. Questions that sounded like a verdict. What went wrong? Why didn't the plane obey? Why did he lower his nose when it needed to be lifted? The black boxes should have provided the answers. The investigators arrived quickly. The Spanish Accident Investigation Commission began work on the same night. The pilots were the first to be interviewed, shocked, emotionally exhausted, but completely confident in their words. They were both repeating the same thing. "We were pulling the handle. We pulled it all the way. The plane did not lift its nose. He just went down." To the investigators, it sounded implausible. The pilot is in training. Severe turbulence. A complex airport, night landing, difficult weather conditions. The first logical thought: the crew made a mistake. There have been such cases. Pressure, wind, limited visibility, all this can lead to incorrect decisions in the cabin. But the claim that the Airbus A320 ignored the pilot's command, it sounded almost seditious. However, the investigation is not based on feelings. It is based on data. And when the experts opened the flight data recorder, the situation began to take on a completely different meaning. The FDR recordings showed that the pilots had indeed both pulled the side sticks towards themselves, and they did it synchronously and intensively. But at the same time, the plane did not execute the command. The trajectory has not changed. The nose did not rise. The plane ignored the input, as if it had not recognized the pilot's movements. And then the data showed something else. The liner began to lower its nose more than before entering the command. It was no longer the human factor. It was the computer's decision. And so a completely new line of investigation opened up for the investigators. Not a crew error, not a control error, but a logical error. An error in the very system that was supposed to prevent such events. Error inside fly-by-wire. The code line, the algorithm, the interweaving of logic is something that no one can see sitting in the cockpit. Something that no one thinks about while the system is working correctly for millions of hours. The weakest point, which was hidden until three factors converged: strong wind, double entry, and critically short distance to the ground. Now the investigators had to understand the main thing. Why did the computer decide that the pilot team was dangerous? And why did he decide to act the opposite way, right in front of the ground? Deciphering the flight parameters took several hours, but the first serious conclusions appeared almost immediately. The investigators slowly studied the graphs, the lines of speed, angle of attack, and movements of the side steps. On the screen, it looked like a series of ripples, bursts, dips, as if the data was breathing, the breathing of a machine that, in the last seconds of its work, was trying to do what it thought was right. And now, the diagram clearly shows how both side steps are simultaneously tilted back. Two pilots are pulling. Their movements are synchronous, almost mirrored. They act promptly, quickly, and fully in accordance with the procedure. In a downdraft, this is the only possible step. Lift the nose, restore lift, and avoid a sharp decline. But almost immediately, the aircraft's response graph shows that there was no increase in pitch. The line remains flat, as if the captain and co-pilot had not touched the controls at all. The investigators looked at this data and realized that this was impossible in the normal operation of the A320. The systems should have at least tried to execute the command. But here, the team wasn't just reduced. It was completely ignored. Why did this happen? The answer lay in how Airbus built its defense philosophy. On the A320, the fly-by-wire system is not just a command transmitter. This is a controller that analyzes every movement of the pilot, deciding whether it is safe to perform it. In particular, there is a very tough defense, which engineers call angle of attack protection. This protection does exactly what is expected of it. It prevents the aircraft from exceeding the critical angle of attack, which leads to a stall. If the computer believes that the pilot's command will lead to a stall, it will restrict or completely block this command. The machine, in fact, goes into a state of, "I know better." In most situations, it really saves lives. But any protection has its limits. And what happened in Bilbao was beyond the scenario that the developers had foreseen. The Spanish Commission has restored step by step the chain of events that led to the blocking of the teams. The first is double entry. 2 pilots were pulling on the side steps at the same time. In the Airbus system, this means that the efforts add up. If one pulls by 50% and the other by 50%, the final command is perceived as 100%. The system does not understand that these are 2 different people. She just sees the total value. The second is sudden changes in airflow. During the final segment of the approach, the aircraft entered an updraft for the first time, then, almost instantly, into a downdraft, then back into an updraft. These transitions changed the load on the wing so quickly that the angle of attack sensors detected data spikes that the system considered potentially dangerous. And the third is height. The Airbus protection system was originally conceived as a tool to prevent stall in the air, at a height where there is room for maneuver, where any intervention by automation has a margin of time for correction. But in Bilbao, the intervention worked at an altitude of less than 100 feet. That is actually above the ground. When the computer added up the 2 pilot commands and compared them with the values coming from the AOA sensors, it decided that the plane was trying to enter a dangerous angle of attack. Now automation has put itself above the actions of the crew. According to the program logic, the system should ignore commands that lead to exceeding the angle of attack, deflect the stabilizer in such a way as to avoid the threat of stall. And that's exactly what she did. She ignored the pulling movements of the pilots and then gave a micro command to lower the nose. At the same time, there was no real threat of stall. The real threat lay elsewhere, in the land that was rapidly approaching. But the system didn't know that. She didn't understand the context. She didn't see that there were less than 3 seconds left before contact. She was just following an algorithm written by engineers. The machine did what it thought was right. But this correct action turned out to be more dangerous than any possible wrong decision of the pilots. Everything that happened after that, the nose bump, the destruction of the rack, the disruption of the trajectory, was a direct result of this single line of code, which forced the system to choose protection at a height where there was no time to protect. When Airbus reviewed the investigators' preliminary report, the response was swift and decisive. The company understood that the problem was not in the pilots, not in the conditions of Bilbao, not in human error. The problem was in the logic of fly-by-wire, in an algorithm that did not distinguish the context. Within a few months, engineers rewrote the angle of attack protection software module for all A320 family aircraft, including A319 and A321. The main changes were based on 2 principles. First, the system began to give pilots more control at low altitudes. Now the automation will not interfere so aggressively when the plane is close to the ground. Secondly, the angle of attack protection stopped working with simultaneous double entry in situations where logic could mistakenly interpret the total command as a stall threat. In other words, Airbus decided, if 2 people are trying to save the plane in conditions of a real risk reduction, you need to trust them, not a mathematical assumption. These changes spread to the fleet very quickly. And since then, for more than 2 decades, there have been no more similar incidents for this reason. The software error has been fixed. History has not repeated itself. But the investigation did not end there. Spanish experts have made several more important conclusions. They recommended to improve weather observation in the Bilbao area, install modern equipment to detect wind shear, limit the performance of such complex approaches by pilots who are under supervision, strengthen dual input training, including the mandatory use of the control intercept button. And the main conclusion was one simple fact. If only one of the pilots had pulled the joystick at that second, the protection would not have worked. The plane would have lifted its nose. I would have gone to the second round. And there would have been no accident. This is not an accusation. This is not a search for the culprits. This is a fact that has allowed the aviation industry to change procedures and prevent similar accidents in the future. Because it was this moment, the moment when two people are simultaneously trying to save the car, that was supposed to be not a reason to block commands, but a reason to prioritize them. After the publication of the final report, much became obvious. But this obvious was only visible in hindsight. Back then, that night, when people stood on the dark strip of Bilbao, hugging each other and trying to cope with the shock, none of them realized that their lives depended not only on the hands of the pilots, but also on lines of code written thousands of kilometers away, many years ago. The dim headlights of the rescue vehicles illuminated the damaged nose of the aircraft. The deformed metal glistened in the night's dampness, like a scar left by someone who could have hurt, but hadn't done so completely. People were standing next to luggage, with children in their arms, with phones that were trying to dial relatives with trembling fingers. They said they thought it was over. They said that the plane was falling forward. They said they would never go to Bilbao again. Many of them later said that at the moment of impact, they felt as if time had stopped, as if no one knew what would happen next. Another blow, a coup, a fire, or a miraculous survival. No one could have predicted it. And yet, the design of the aircraft stood up. The same Airbus A320, which had clearly made a mistake seconds earlier, nevertheless saved its passengers with another part of its engineering, the strength of the structure. In the cockpit, the pilots experienced a completely different range of emotions. The young co-pilot did not even try to hide his shock for several days. He sat in silence. He spoke in broken sentences. He repeated over and over again, "I pulled. I did everything right. Why didn't he obey?" The captain, an experienced man who had been in difficult situations before, also could not find soothing words. He knew that the student was flying the plane the way he was supposed to. He knew that he had intervened correctly, and he knew perfectly well that no matter what the investigators said, no matter what the press suggested, the real reason was deeper than the mistake of a human hand. For the investigators, this case has become unexpectedly difficult. Not because the data wasn't accurate enough, but because the usual scenarios didn't fit. It wasn't a pilot's mistake. It was not a violation of procedure. It wasn't a technical malfunction in the usual sense. It was a clash of the philosophy of automation with reality, where a machine and a person understand the concept of danger differently. The algorithm saw a stall threat where there was none. The man saw the threat of a collision where it already was. And there's not a millimeter of room for error between them. After the official investigation, Airbus rewrote the logic of the protection. And it was a rare moment in the history of aviation when the manufacturer recognized, yes, we have created a system that in one very pronounced case does not work correctly, not unsafe in general, not erroneous in normal operation, only in one, but extremely dangerous, combination of factors. And this combination happened in Bilbao. Now, in the modified version, the system no longer intervenes so aggressively when the aircraft is low above the ground. Pilots now have more manual control in those seconds, where human decision can be faster than calculation. Now, the double input is no longer perceived arithmetically as one big deviation, but is handled more carefully. Every line of code, every algorithm has been rethought from the perspective of, what if two pilots are trying to save a life at the same time? And this has become the main legacy of Iberia Flight 1456. Not loud, not widely known, but very important. Thousands of planes are flying today using the updated logic that was a direct result of that night. Thousands of crews are receiving instructions based on the findings of that investigation. Thousands of pilots know that double entry is not just a training error, but a signal of a change in the situation, a threat, an internal conflict that needs to be resolved instantly. And the passengers who flew on that flight will probably remember for the rest of their lives the sound of metal on concrete, the rattle of the landing gear, the crash-like impact, and the silence that came after. But for aviation, this flight was a reminder of something else, that the ideal system is not one that never makes mistakes, but one that knows how to learn. And to some extent, it can be said that it was the people who survived that nose bump on the concrete of Bilbao who helped make flights safer. Their fear, their randomness, their incredible luck. All this became part of the chain that saved the lives of those who flew after. After all, aviation always moves forward through such stories, through the study of errors, through the reworking of algorithms, through the understanding that there is no competition for power between man and machine, but a search for balance. A balance in which both can make mistakes, but together they are still able to keep the plane in the air. And Iberia Flight 1456 is a story about just such a balance, about that brief moment when everything could have ended differently, about a system that decided differently than the pilots should have, and about the people who went out into the night alive anyway. Perhaps this is one of those rare cases when an accident was not the end, but a lesson. Quiet, heavy, expensive, but it changed the future.